So you expect to get your quiz number 2 before this weekend. So usually I like to post a new quiz on Friday. On Friday, all right? But sometimes in the middle, it's also possible. Because if I think about, sometimes if I just wait till Friday, I may waste a few days. But today already Wednesday. So then we do not need to wait too long, just 2 days. You will get your quiz number 2. Next, we need to prepare for our programming project number 1. Last time I gave you case study number 1, university view. I forgot. I haven't posted material. Notes tutorial. I will do today. Today I will check everything. Including the videos. I finished processing videos. I will post. Try to make sure I post everything we need today. So then today, I like to give you our case study number 2. Number 2 is still that university example, but I just add one more feature to it. So we have a sequence of 3 case study examples, all about university. Same database. So we just display the data. There are 5 tables in the database. So we display that. Then probably, so here I just, let you know my plan for our first programming project. I may like to work on this university database, but I ask you to do some other basic features. Okay, So let me give you some estimate time that not this week, next week I will post our first programming project. Okay, next week. So I finish go through these 3 case study examples. Each one has its tutorial. Okay, so you just study my tutorial. You can understand all the code in the example, easily. So I explain all the details you need. So then, hopefully, get you ready or close to starting our first programming project next week. Okay. All right. So that's the plan. Now let us start a new module, module 3, SQL basics. So in this one, before I start to do a lot of SQL statements, queries, I like to give you a lot of basic SQL background knowledge. Before this point, we study the general database DBMS knowledge, but here we need to focus on the SQL part. After this module, SQL basics, then we can work on SQL commands. Okay, so you will have large number of SQL queries you need to work on. Okay, all right, so let's start the part A of module 3, understand SQL structures. The first topic, 8.1, database schema. First, let's look at the schema concept. Oh, yeah, that one. I need to dismiss that window. All right, so here. Oh, also turn off the light. Better. All right. Good. All right, so let's start. Our first topic, database schema. Very basic concept. Yeah. First, description of a database. Yeah. Database schema, so later you will know, just database script. All right. Here, because after some time, you may get confused. Yeah. All right. So here, I give you that animal DB example, and for my case study examples, I will give you that university DB.SQL. So we call that database script. All right, we run that database script. So the database script contains two parts. All right, the first, table structure part. Okay. All the table definitions. All right, yeah. Second, the data part. Yeah. Data insertion. All right, yeah. The schema, we talk about the table structure part. All right, not excluding data part. Schema does not include data. Okay, yeah, exclude data. Exclude data. Okay, yeah. All right. Specified during the database design. Yeah, when we design a database, we need to design table by table. Okay, so each table you need to really do some serious design job. Okay, and especially many tables are correlated. So you need to, do some, non-trivial. That's non-trivial. Sometimes you need to consider many factors. All right. Not expected to change frequently. Yeah. So this line, I like to make some comments. Yeah. Not expected to change frequently. You can change. All right. You can change, but changing the schema part, it's a relatively big thing you need to consider because its impact could be big. All right. So we say, the reason we say not expect to change frequently, we say the change is a, big thing to be considered in your business. Okay, so But here, another thing is based on my own experience. Yeah, so I developed some real world web applications. When I do that, I need to design a database. Yeah. Only one person, myself, worked on that project. So no other people involved. So that means I have the freedom to make all the decisions. Yeah. So that's different because if you work in a big team, then when you change something, so that may not be very easy because you need to, do communication with many people. Okay, and but for my own project, the project actually pretty big. The database is quite big. Yeah. All right. But still, I remember I have more than 100 tables. So that big. Okay. Yeah. So that's not small project. Pretty big project. But I make all the decisions myself. So my comment here means not expect to change frequently because when I make the decision, I change frequently, right? Because not so many people involved. Yeah. When I feel there is some special reason I need to change, then I just change it. Okay, yeah, but I need to make sure I do not mess up with my data. Yeah, yeah. Actually, it's very easy to control. Yeah, very easy to control, not just corrupt your data. Yeah, yeah. All right, so that's this comment. Yeah, schema construct. Yeah, entity, the first one, entity. Yeah, it is a row in a table or a record. Yeah, entity. Yeah. So here, when you look at this object, here we can call it an object, a general object. When you look at that, when you look at from different views, the names could be different. Right? A row in a table, right? So you use that visual way. Yeah, table, you can imagine there is a table, 2D rows, columns to organize your data. Yeah. Then one row corresponds to one entity. Okay. So then from the business point of view, one record for one entity object. Yeah. So that from different view. Yeah. All right. Represents a real world object such as employee. Yeah. Real world project. Yeah. You need to provide the properties for this object. You want to store information of different aspects of this object, the entity. Okay, yeah. All right. Attribute concept. Attribute, yeah. Yeah, so that's the property we talk about. A column in a table. In a table, we refer to each attribute that is a column or field. Sometimes we also call field. Okay, yeah. Or a field. Yeah, that's the attribute. Yeah. Represents some property of interest on an entity, such as the employee's name. Yeah. Okay. Next concept, relation. Yeah, relation. Here in our database concept, that's a table. Okay. So that's the official name, academic name, because the database, this theory originally started in academia, after a lot of research, finally, when, all things considered, finally, we get that product in the business world, DBMS, a product, but a lot of research in academia, before we can get a product. Okay, yeah. All right, table types. Here, there are two table types, basically. The first type, entity type. We just talk about entity concept, but here we store the entity information, employee information. So that's the typical entity type tables. Yeah. All right. The second one, you may not be familiar with. It's called a relationship type. It's different from entity type. It describes the relationship between some entities. Okay, yeah. A relationship among two or more entities represents an association among the entities. Yeah, so here, this association thing, relation. Okay, yeah. And also, that's the mapping. Yeah. We create mappings among or between, because usually between two entities. Yeah. Usually between two entities. If more than two entities, then we need to join many different tables. Okay, that's possible, but we need to do some join operation among multiple tables. Yeah. So yeah, we will get there. Okay. All right. Yeah. So relationship type table, also very useful. Yeah, because usually people are familiar with the entity type table, but not quite familiar with relationship type table. Yeah, but it's very useful. So here I like to explain a little more with two examples here. The first example, work on relationship between an employee and a project. Here, you can see here we mentioned that employee table many times. Why is that? Because later, remember our first database in this textbook is the university database. All right, DB, okay. Our second database for this textbook, actually the second one is used much more than the first one. Yeah. First one, after the first two chapters, then we won't use, starting from chapter 3, we will switch to second database. All right. The second one we call a company database. Yeah, I will post that database script to you, probably next week sometime. I can post the second company database. In the company database, there are many tables, 1, 2, 3, 4, 5, at least 5, 5 or 6, based on my impression. And employee is one of the company database, one of the tables in that company database. Yeah. So here, and work on is another table, work on table, okay? Yeah. But the work on table is a relationship type table. Yeah. Other than this one, in the company database, all the table except the work on, all are entity tables. Yeah. Only this one, work on. This is the relationship table. Yeah. All right. Between an employee and a project. So between, that means each employee could be mapped to multiple projects, right? Because usually in a company, one employee could work on more than one project. Yeah. How to store that information? Using this relationship. Yeah. Each employee, you use employee ID. So there is one employee ID, okay? Then each project, there is a project ID. So you use project ID to identify those projects, okay? So then you need to create a relationship, a mapping. So what is the mapping? So here, you may ask me, the question should be how to represent a mapping between two entities. Yeah, all right. The question. Answer, it's pretty easy. Just create one record in the, the relationship table. Relation type table. That easy. Okay, so easy. Okay, one row, one record. You specify first entity ID and a second entity ID, but you need to have a primary key for this row, this record. Okay, yeah. So remember, with a primary key, okay, yeah. for control, right? You need a primary key so you can access, manipulate this relationship, this mapping. Otherwise, how to access it, how to work on it, right? It's hard, yeah. All right, yeah. That's the first example. The second example, a relationship between a math problem and a category. Yeah. Math problem, we need to allocate all the math problems in the database to certain number of categories. Okay, yeah. So that's the mapping, that's the relationship tables we need, and allow M-to-M mapping. Yes. So here, the relationship, when we talk about relationship, okay, think about the way 1 to M relationship. Okay, so one entity, it could be mapped to multiple second entities. Okay, 1 to M. All right. Okay. M to 1. Yeah. Multiple first entities to one single second entity. All right. And now another type, M to N mapping. Okay. All right. So let us use our second example to see this M to N mapping. Okay. All right. Second example. Math problems. Look at entity number 1, math problems. Right? Yeah. We expect to have a list of math problems. Yeah. And the categories, second entity. Another list of categories. Okay. So think about M to M mapping. All right. Look at this. Multiple, look at this side. Multiple problems can be assigned to same category, right? Yeah. This is M to 1, right? Okay, M to 1. All right. Then one problems could be allocated, assigned to multiple categories, right? One math problem, it could belong to algebra category, geometry category, trigonometry category, and so on, right? So that's 1 to M relationship. All right, but we have both of them overall, so we have M to M, right? Yeah. Okay, yeah. That's the meaning, M to M. Yeah. Quite natural. In the real world, we need this kind of relationship mapping in our business. Okay. All right. History of schema. Yeah. Here I just talk about a little bit history. Okay. Yeah. 2 versions. Yeah. Early version of SQL did not include the concept of a relational database schema. No such concept. Yeah. Here, let us go back to the research stage, that time, early time, okay? Yeah. In research, okay? The product, possible, not very good product, okay? Research, so when those researchers start design the structure of DBMS, at that time, they didn't have the schema concept, okay? So they didn't organize their tables based on the schemas, okay? Or schema here, one schema corresponds to one database, okay? One database, all right, yeah. But at that time, not organizing. So here you can see at that time, all tables were considered part of the same schema. What's that? You can see quite messy. At that time, things quite messy. Yeah. All right. to trigger my, something, yeah, put it away. All right. So why I call it quite messy, because think about it. We have multiple projects in business. Okay? We have many projects in business. For each project, we need to have certain number of tables, right? Yeah, certain number, yeah. But at that time, when you need to use the DBMS to store the tables, all the tables, they are stored together, all right? In one pool, in one big pool, yeah, because they call part of the same schema. Yeah. The whole pool, that is one schema, okay? For whole business, all projects, you see, hundreds of tables related to dozens of projects, okay? But they all sit at the same pool, same place, very difficult to work on, right? So definitely it is a bad way, okay? Yeah. So let us look at improve, starting with SQL version 2, then the researchers, so they changed the structure, yeah, so improve it, group together tables and other constructs that belong to the same database. Now, you see, same database. All the way, all tables from all all databases, let's say this way, all right? Yeah, let's say this way. Tables from all databases, they are stored at the same place. Okay, no separation with respect to different projects. Okay, yeah. So you can see, yeah, the later version, yeah, one database can cover only those tables used, under this project, under the project for this, under the database for this project. Yeah, all right, okay, under the same schema. Yeah, so, all right, okay, yeah. All right, yeah, so that's our first topic, 8.1, database schema, okay, that background information. Right. Second, 8.2, database language, yeah. Because sometimes you may see people talk about database languages. Yeah. So here, let me talk about some commonly used database languages. Yeah. We know SQL is a database language, but there are some other languages people call. Here, we still will go back to the, research in academia case, because those researchers, they design different database languages, okay? The first one, it is called Data Definition Language, DDL, yeah. DDL, yeah, because you will have a lot of chance to see that DDL, okay? So in database literature, so you will see that this, these notations, DDL, okay, yeah. Define schema. You have seen, yeah, I give you the table example, how to create a table. That's the DDL part, right? The way we define a table, that's the DDL part, okay, yeah, all right. View definition language, VDL, view. This time, the focus is at the view side. Yeah. How to view the data. So you need to use another special type of language called the VDL, yeah. View definition language. Yeah. How to define a view, right? Yeah. Specify user views. Yeah. Okay. Yeah. I talk about that view concept before. Virtual table, right? virtual table. Yeah. Here the view, yeah. So you can refer to that, virtual table. Yeah, that's the views. All right. DML, data manipulation language. Yeah, manipulation. Do the query operations, manipulation language. Yeah. Include retrieval, insertion, deletion, modification. So that's the, typical operations we use in a DBMS. So it's called DML. See, yeah. So different names. Yeah. But in SQL, it is a comprehensive integrated language. That means it covers all these things. Okay, all these, the above three types, all included inside SQL. Okay, yeah. All right. Yeah. A combination of DDL, VDL, and a DML. So we can do all those things. Yeah. Statements for constraint, specification, schema, evolution, etc. Yeah, more than that. Okay? Yeah, other than those, more than that, SQL can do much more. Okay, all right. Yeah. So that's this topic, database language. Then we move to the next topic, properties of SQL. Yeah. All right, we try to learn important property. Yeah. So here I just use my old style. All right, the standard language for commercial relational DBM. Yeah. So I mentioned that before. Standard, yeah. Industry standard. That means all DBMS vendors should adopt this standard. DBMS vendors, okay, should follow the same standard, industry standard. All right. Yeah. A comprehensive database language. Yeah, we know its meaning. Yeah, we just discussed in the previous slide. Yeah, both DDL, DML. Yeah, it has facilities for defining views on the data. Yeah. Virtual table views on the database, specifying security and authorization. Yeah, so the privilege, said that. Yeah, defining integrity constraints. Yeah. So later we will see we can write a SQL statement to define constraint. Yeah, different constraints. Yeah. Yeah. All right. Specifying transaction controls. Yeah, I talked about the transaction concept before, right? Yeah. Transaction controls you can do in SQL. Yeah. Rules for embedding SQL statements into a general purpose programming language. Yes. Here we get to the programming side, embedding SQL statements. Yeah. Here, let me talk about this topic a little bit. For a general purpose programming language, here we use two examples. The first one, Java. The second one, PHP. All right. Yeah. In Java and PHP, we need to write SQL queries. Yeah. So we need to write SQL queries. Right? Yeah. All right. Yeah. So when you do that, you need to communicate with DBMS. Yeah. So the general purpose programming language, you need to find some way to communicate with DBMS. Yeah. And Java and PHP, they use different ways for the communication. Okay, yeah. PHP uses a straightforward way in PHP. So what do you mean straightforward way? For example, PHP when you need to write a code for MySQL, there are a set of MySQL functions you can use to do the MySQL queries. Yeah. Last time when I show you my case study number 1, I show you some MySQL connection code. You can see that MySQL word is in that function name. Okay, that's you can only use those functions for MySQL queries. That means when you switch to Oracle DBMS, you have to use a different set of functions. Okay, yeah. But Java takes a different approach. Java create the same interface for the programmers. Yeah. So Java is very special. The Java JDBC technology, Java JDBC technology, Java database connectivity. And Java uses a common interface. For programmers. In PHP, there is no common interface for programmers. What do you mean the common interface? It means you basically use the same Java code for different DBMS. For Oracle, for MySQL, and for even other data DBMS, you use the same set of Java code. Here, I want to put it in a precise way. So you use same set of, we mean, classes, methods, those things, set of Java code. All right, yeah. But the SQL statements could be different. So because here I talk about Java code. At the Java code part, the same, exactly the same, no change. But SQL code, SQL statements could be different for different DBMS, could be different for different DBMS. Okay, yeah. Yeah. So we understand that, yeah. So, but SQL statements, that part is used as the parameters of some Java methods, all right? Parameters, yeah. We pass SQL queries as string values to certain Java methods, okay? Yeah, so that's different from the Java code, okay? The Java class names, method names, different from that part, yeah. But PHP, that's different. Your function name, you need to change function names when you need to change DBMS. Okay, yeah. So that's the difference. Yeah. So that's, yeah. Why call it embedding SQL statements? Yeah. So inside your programming language, you use double quotes to embed SQL statements. Double quotes around SQL statements. Okay, all right. Yeah, so that's the properties. Yeah. Structure of SQL. Yes, yeah. Core specification. Yeah. That part, that's the standard part, core part. Okay, must be followed by all the vendors, all the DBMS vendors. Yeah. Supposed to be implemented by all RDBMS vendors. But here, when talking about supposed to, that means probably some of the vendors may not follow exactly, yeah, but you can expect, you know, most part of the SQL should be implemented, yeah. Specialized extension, that part, it does not belong to core specification, then quite different. Yeah. For different vendors, they have their freedom to do this part. Yeah. I talked about that before, the consequence. Yeah. For our programmers, we as programmers, we need to do conversion. That's the tedious work. Not easy, yeah. Tedious and pretty difficult. Many times pretty difficult. In application programs, when you change a DBMS, you may need to change your SQL statements, yeah, mainly related to the extension part. Okay, yeah. But the hard thing is, we don't know which part belongs to core part, which part belongs to extension part. Nobody, you know, usually the people are not familiar with that. Okay, yeah, just by experiment. If it doesn't work, then we feel probably it is the extension part. So you need to find a solution. You need to search the web, study the documents, and see how to do the conversion. Okay, yeah, all right. Then SQL terms, yeah, we saw a little bit, yeah. So here the SQL terms, yeah, in the academia, design, research stage, yeah. So you can see people, researchers, so they, create the terminologies, yeah, yeah. All right, yeah. SQL, yeah. So relational model, yeah. Yeah. Yeah, SQL uses relational model, all right? Yeah. Table relation, yeah. So table, yeah. When the users use table, from users' perspective, users like to call table, right? Yeah. It's not very common for users to call relation, okay? Yeah. Yeah, but for researchers, they like to call relation. Okay, yeah, all right. So row, tuple, yeah, column, attribute. Yeah, the second line called by researchers. Okay, the first line called by users. Yeah, all right. Tuple, yeah. So that's an ordered list of elements. Order is important. Okay, yeah. So this set, yeah. Ordered, yeah. Not like set concept, because if we talk about set concept, order for set concept, the order is not important. Here in DBMS, we need to use set a lot, okay? Set and a multi-set, yeah, we use that. When we use those concepts, you just know the order is not important. That means when you change the order, you get the same object, all right? When you rearrange the order, you do not get a new object. You have the same old object. So that means you are using a set. But for tuple, it's different. If you rearrange the elements in a tuple, you will get a different one. Okay? Yeah. The order is important. All right. Different, yeah, from the set. Yeah, here. The set is an unordered list of elements. Okay, all right. Then the last, yeah, we have 10, yeah, actually we have 20 minutes, right? Yeah, 20 minutes. Yeah, let us do 8.4 PHP programming. I show you our second case study example. University sort. Yeah, I add a feature, sorting feature. Yeah, university in our first one, we just view the table. We do not change anything in the view. All right, but in our second case study example, we add a sorting feature for each table based on each column. Yeah. When you do the sorting, you need to base on one particular column, right? Yeah. So we add that feature. So I will show you in my demo later. Yeah. But before I show you the demo, let me talk about the main query statement in this example related to the sorting. Yeah. When you list all the rows from a table, you can specify order. Here, I use the boldface, order by a column name, okay? Or field name. Yeah. In this example, we store all the fields in one fields array. Yeah. So we store all, yeah. So in the case study number one, you can see how do we store all the fields in one array, this fields array. Yeah. Here we just access it, okay? Yeah. $CM, we know the PHP variable, C refers to column, all right? N refers to number, CN refers to column number, okay? We need to get a column number or the column index in the array. We pass that index to this array so we can retrieve one particular column name. So then when we order by, we use this, we do the select statement, the query, we list all the rows, but we sort by based on that particular column. Okay, so if it's a string column, then we use the alphabetic order. If it is a numerical column, we based on the value. Yeah. Here, you may ask me order by ascending order or descending order. Yeah. So there are two cases, ascending order and a descending order. Yeah, you can. But ascending order is the default case. Here you can see we say order by, we didn't specify ascending or descending, right? Yeah, because that means descending. Oh, sorry, that means ascending because it's default. Default, okay? Yeah, all right. But for descending, it's not default. Descending, you need to specify the keyword DESC, okay? So order by insert DESC in front of your field names. Yeah, yeah, definitely with a space, separate. Yeah. DE and ascending, there is a keyword for ascending, ASC, ascending, yeah, because it's a default case, so people do not need to use. If you like to, you can, yeah, for readability, for better readability, yeah, yeah. But here we do not use it, yeah. All right. So that's the meaning of this statement, yeah. All right. Let me just run this example. Yeah, it's pretty simple, pretty straightforward. Yeah, I just play around. Yeah, after you download it, you have your database exam set up. Then you can run these examples. Yeah. All right. Yeah. Okay, yeah, so let me go to the, because I run it, so it is ready now. I can show you the outcome immediately. Yeah. All right. All right, so let me switch to that page. Yeah. I need to stop sharing first. Then I switch to that university example. Then let me share it again. All right, so now you see the interface. Yeah, similar to the one in our university view. Yeah. Here you see larger font, but remember I put under each column, I put a sort button. I put a sort button. Yeah. Okay. All right. When I click sort, first one, you can see all the rows are sorted based on the first, I click the first sort button. Yeah. In ascending order. Now, let me click the second one, new alphabetic order sort. Yeah, so you can see with respect to the second field and so on. All right, yeah. Last one, the name alphabetic order. All right, you can change to different tables. For all the tables, we have that feature. All the tables, we have that feature. Okay, courses, we have that feature. Okay, yeah. All right, sort. All right, sort. Yeah. Okay. Yeah. That's it. All right. Yeah. But here, when you can see comparing the change we did from the first case study example and the second one, the change is not much. The change at two places. The first place we just discussed, that order by. We're only at that part, order by. That's simple. All right, the first one. The second one is at this sort button. How do you make the sort button to send the SQL command or send a request to make that sorting request? That's the second thing we need to add. We need to use a JavaScript function here. In a JavaScript function, we pass a new request, the query string for a new request, right? Yeah. So we need to specify the table number, which table you want to do the sorting, right? So that's the first piece of information, first parameter. Other than that, you also need to specify the second piece of information, the column information, two numbers. Yeah. Remember, we use the parameter MN, menu number in our first example, MN, $MN to select table number, table, okay? Here, we use the second PHP variable, $CN, about column number, second parameter. So we use two query parameters to control how do we display one table sorting based on one particular column. Okay, so that's the modification from case study number 1 to case study number 2. All right. Then, similarly, for case study number 3, I did another small modification. Now, still the sorting thing, but in the third case study example, I put 2 buttons. Because when we do the sorting, we have 2 different ways, ascending order and a descending order. Yeah. Then I associate two buttons under each column, one ascending arrow up, one descending arrow down. All right, you click arrow up, you sort ascending or in ascending order, or yeah, probably just the opposite. Yeah, just one ascending, one descending. Okay, yeah. So that's my third case study example. I will give you next time. Okay, yeah, next time, yeah, including the tutorials. So then you will study. You can study that. Yeah, and in case study number 3, because I need to use buttons, I need to use arrow up, arrow down buttons. So I remember I used that a special package called a Bootstrap package, the Facebook Bootstrap CSS package. Yeah, we just use, the buttons there. We do not need to create by ourselves. We just use their existing GUI components. They design many, beautiful GUI components. We just use theirs. All right, yeah. All right, so that's pretty much what I like to cover in today's class. Yeah, it's rare. I still have a few more minutes. Yeah, but I do not have much to talk about. Yeah, I just like to stop right here. Yeah, so we